Two-step equations. Well, once you've mastered the one-step equation, two-step equations just says that there's two items to do. Well, if there is more than two things to do, and this applies to any mathematics, you follow the order of operation where it's PEMDAS. Now, here's the thing about algebra, okay? If I'm looking at an algebra math problem, there's already an answer. So PEMDAS, if you go from top to bottom, you are actually looking for an answer. There is no answer. But with algebra, we already have an answer. So we're not going to move in a downward fashion. We're actually going to reverse the steps of PEMDAS, where it makes any additions and subtractions first, then multiplication and division. So you'll notice in our first math problem, I have division and I have addition. Well, if I reverse PEMDAS, that means that I'm going to want to get rid of that add 3 first. So let's go ahead and give it a shot. So if I have division and addition, I'm going to reverse PEMDAS. So I'm going to get rid of add 3 first. So I'm going to be left with x divided by 4 equals 10 minus 3. You see how that works? Notice that I still left x divided by 4 on the left side of the equal sign because it's still there. We haven't done anything with it. We moved the plus 3 to the other side. So we're going to do this step by step. Again, two-step equations. So 10 take 3 is going to leave 7. So I'm going to be left with x divided by 4 equals 7. Now I can move to the opposite of division. What is the opposite of division? Multiplication. So I want to multiply the other side by 4. So I want to have x equals 7 times 4. See that? And 7 times 4 is 28. And there's my final answer. Let's try this again. All right, let's do this. Let me erase. Let's do this one right below it. That looks like fun. Okay. So look at what you got here. I'm taking x and I'm multiplying it by 2. I'm also taking x and I'm adding a negative 2 to it. So what thing do I get rid of first? Do I get rid of multiplied by 2? Or do I get rid of adding a negative 2? If you said, hey, let's get rid of that add negative 2, that's correct. Remember, addition and subtraction are going to go first. So I want to do the opposite of adding a negative 2, which is to take the other side and subtract a negative 2. So let's rewrite. Here we go. 2 times x equals negative 10 minus a negative 2. Okay. Now that I've done my algebra, look at this. Do you see the integers here? Do you see how you're subtracting a negative? Well, that's an integer rule, right? And that rule says that if you're subtracting negative, that means to give back. So that's really negative 10 plus 2. So if you'd like to, you can rewrite so that you don't get confused if you want to. And that's what I'm going to do. I'm just going to rewrite it. Did I change anything? No. All I did was apply the rule so that I could visually see plus 2 for myself. And hopefully I don't get confused when I'm combining. So negative 10 adding 2 is going to leave me a negative 8. So that's 2 times x equals a negative 8. So let's continue. The opposite of multiplying x by 2 is to divide the other side by 2. So now I have negative 8 divided by 2. That's going to leave me x equals a negative 4. So this is what it means to be two-step. There are some more here. I think we should do another. What do you think? Let's do another one. I like this one right here. Let's do this because something interesting is going to happen, but not too interesting. But it is this is a one-step. Let's do this because it is going to show something, okay? Do you notice if you have a negative 2d and you add a d to it, can I simplify those? Yeah, I can put those together. Now watch this. A negative 2d plus a d is going to leave me a negative 1d. Now, in algebra, they don't really write this. See what I'm writing? Where I wrote negative and then I actually showed the physical one. Do you see that? In algebra, anytime I see a variable, like for instance, do you see this one? Do you see where you want, if you want to say, is that negative r? Not really. What's really there is negative 1r. But anytime I see a variable, like for instance, that one, you'll say, well, is there any, how many h's are there? I'm going to tell you one. And you're going to agree, yeah, that's an h, right? That's one h. It's not just h, there is one h. There is one f. So if you see the variable just by itself, there is a one in front of that. So let's get back to what this is now. So I won't show negative 1d. In algebra, they'll show negative d equals negative 10. See that? Sometimes it can get a little confusing. And it can get confusing about what I'm going to do on the next step. Now, when you see negative d equals negative 10, you might say, am I done? Is this it? And the answer is kind of no, because really what's showing is this. I still have negative 1, and I'm multiplying it times d. Well, I have to get rid of all kind of multiplication, right? Anything that's happening to the d has got to go away. So let me erase this so you can see what we're going to do next. So that's negative 1 times d. So what's the opposite of multiplying d times negative 1? It's to divide the other side by negative 1. So I'm going to have d equals negative 10 divided by negative 1. And a negative divided by a negative is a positive. So that's going to leave me with d equals 10. Now, a lot of times students have been shown different things in their math classes through the years. They might just say, hey, you can't have a negative d, flip the other side, or whatever they're saying. But I just physically want to show it to you that this is really what's happening. You see a negative 1d. I like to show it, especially to my students, because I want them to understand why the next step happens and why this occurs. That it shouldn't be magic, and I try to take away all the mystery of math.